Hello, I'm Rassim Chettfour.
I'm Nash Iyer.
I'm Cassie Argumedo.
And I'm Jonathan Sussman, and we've developed MuscleMeter.
Muscular disorders such as muscular dystrophy affect millions worldwide. These disorders are characterized by muscle degeneration and weakening. There is currently no easy way to quantitatively measure and track the progress of these disorders. We have built a device that measures isometric voluntary contraction for 4 different muscle groups most impacted from muscular degenerative disorders. We have also developed software to guide a user through the test and analyze and present the data.
Our device consists of 3 main components: 4 sensors, a digital to analog converter, and a physical structure. We use 4 load cells in our clamp system. Each sensor produces an electric potential based on the force applied. We are using the MyDAC digital to analog converter to record the electric potential from the load cells and convert it to a force reading. Each MyDAC can accommodate 2 load cells. In order for the sensors to measure data, the force sensor must remain stationary when the user applies a force. This is why we built our own device that has 2 clamps that will hold the sensors, one for each limb. We use the LabVIEW software environment to collect, store, and analyze the measured data from the force sensors. The patient is instructed to sit on the plate, and the straps are fastened around the right leg tightly so that the leg is immobilized. A technician opens up the main launcher where they are prompted with 2 choices: record data and read data. The technician first chooses to record data, launching the data acquisition application. The technician has the choice to either select an existing patient or create a new patient. In this case, we will select an existing patient. There are 4 different muscle contractions we are testing: internal arm rotation, external arm rotation, leg extension, and leg flexion. The technician will click on the tutorial video to show the patient how to perform the test.
Place your elbow on the elbow pad and place your wrist between the 2 gel pads, like so. When you see the yellow light, press your arm towards you as hard as possible while keeping your elbow in contact with the gel pad. Hold for 5 seconds.
After watching the tutorial, the patient waits for the yellow light, indicating that the test is waiting, and then presses as hard as possible for 5 seconds. The green light shows that the test has started. Once the green light has turned off, the technician saves the trial and can complete the remaining tests. Once the technician completes a test, the technician can end the session, the patient can be dismissed, and the technician will be redirected to the main launcher. To view the data, the user can launch the data display application from the main launcher. A password is required to enter the application. From this application, the user can select a patient. The user can view the complete set of raw data on the left panel. Each test shows the name, date, and time it was conducted. The plot on the left shows the force measurements over time. The average, maximum, and standard deviation values are displayed to the right of the plot. The plot on the right shows how the data changes over time. For each of the tests, the user can flip through plots showing the change in maximum, average, and standard deviation. The blue points show the patient's data, and the red points show standard values for that particular measurement.
We hope this device and software can be used by physicians to track the progress of patients with neuromuscular disorders to help select the right treatment. We also hope this system can give patients more knowledge and insight into their condition and ultimately improve their lives.